Electrolytic capacitors. Done 1, 2, 3. All ticked off. Thank you very much, Sergeant. BNC connector. Well, you can't exactly get that wrong, can you? Unless you're stupid. Now this is a classic case of a very large, well, very large in the context of a circuit board, body of metal, a large metallic mass. This is going to draw heat away from the soldering iron, so you need to use a lot of heat on this to get it soldered in. Soldering onwards. Okay, almost done. We're getting them, you old mucker. I was thinking to myself, oh, should this be on this side or on the other side? Now I thought, well, why on earth would it be on the other side when all the other components are on this side? So yeah, obviously it's going to be there, isn't it? Look at my other sheet to make sure I'm right. Pretty sure I am. Yeah, of course, because why would it be on the back side? See this part here? This, that's the socket I was showing you just now, the large metal thing. It's on the other side of the board. On the opposite side of the board as shown in this picture. Because why wouldn't it be? You know, why would it be anywhere else? Yeah. Hang on a minute. Wait a second. What? What's that about? Analog board. Oh yeah, of course. I'm on analog. I'm on the analog board side, aren't I? Click. Oh, that sounds nice. Clicky clicky. Look at that. Oh, very satisfying. Oh, misses. I do say. Right. Oh, hang on a minute. Hang on. Hello. Earth calling Matthew. There's a diagram here where it's on that side. Look there. Yeah, just there, mate. Okay, as if they're saying to me, hello, are you there? Wake up. Right. Fold that in. Ramp the temperature up to about 390. Make sure that socket's in nice and securely. For this metal socket, whatever it's called, this terminal, I'm going to rest it against these pliers here. Make sure it's nice and secure. Make sure it's not going to. I'm using the fact that the top of these pliers are protruding to push upwards against the socket to hold it in place. Over-explain that again. Never mind. At least I'm trying to explain it. That's the main thing. Right, it's on 390 centigrade, so it should be hot enough. I hope. Maybe not quite. Let's try 415. You need a lot of heat to get these solder to melt when it's touching high thermal mass components, because yeah, it needs to account for the large mass of metal that's trying to heat up. Could take a while to heat this up. Actually, how hot does this get? 460. 460? It's a 450. So if I put on 435, that should be hot enough. I'm hoping. You need to hold the iron against the metal post for quite some time to heat up allow the heat to transfer through the blob at the end of the solder tip, the iron tip, into the metal body. Allow the whole thing to heat up, I think. Otherwise you're not going to solder it in. Ah, there you go, it's flowing now. It's flowing in now. Flowing, flowing, flowing. Yep. Make sure it's not a dry joint. It could be, because it's No, that's good. Bit blobby, but it's good. Mr. Blobby. Mr. Blobby. That's nice and flowed. Now I've done that, I can take the pliers out of the way. Right. Do the other side. Wipe the iron down because there's all this dross all over it. Blob up the tip a bit more because it needs a bit more solder to flow through. Let it heat it up by holding it there. That's called dwell, isn't it? Don't dwell on it too much. Let's do that one again. Yeah, it's a bit blobby, but you know, to be honest with you, I'm quite happy with that. It's nice and shiny. If a joint isn't shiny, it'll have no integrity because at some point or another, it will fracture because the structure of the solder will probably be crystal. Oh, that's red hot. I forgot about that, didn't I? The structure of the solder inside the joint will be crystalline, sort of. What's the word? If the joint is dry and dull, and sort of frosty looking, it'll be the structure of the solder internally inside the joint will be crystalline and sort of granular, I suppose is the word I'm looking for. You know what, that'll do. And now, get me tweezers, get the back pin, bend it out carefully. Lower my temperature back down to 390. But this metal pin is not particularly high thermal mass. Is the temperature settled yet? Yes. Solder that. A bit of solder. A bit of a blob. There we go. Check it with the old magnifier. Looks alright to me. I think. Right. Whatever you do, check the joints of the sides of the connector shell, because this one here is slightly under soldered on the back. So give your eye on there for a bit and run a bit more solder through there if need be. It's slightly undertaken at the back. It's not taken to the post properly. There we go. That feels right. The back of the joint, the solder fillet, the blob, hadn't surrounded the post properly. It still hasn't actually. Let me try again. Yeah, it's a high thermal mass part. It's a lot of metal in there, so you need to overcome the heat. So you need to overcome the mass of the metal that you're heating and solder it to the board. So don't be afraid of using moderate heat, you know, quite high heat to get that in there. Yeah, that looks okay. Surely better than a lot of joints on products I've seen from China, that's for sure. Right. At least I know I've done it properly. Whoops. Do I trim that too far now? Maybe I should reflow that again, just in case. There we go. Soldering is quite an art, you know. Smouldering iron. Check the other side as well. If you need to, apply a bit on the back of the thing as well. The back of on the other side here. Apply a bit of solder there if you need to as well. Because you can't go back and do it again once it's been assembled. Are you with me? Once you assemble the kit, you can't go back and do it again. Well, you can, but it's a right faff, so. There you go, that's all in. Yeah, that's okay. I can't show you very well. Yeah, that's a nice joint, that is. That's a nice joint, said the hippie. That metal, don't forget that metal body here. This shell is still really hot. It's absorbed a lot of heat. Take a few minutes to cool down. Yeah, don't touch this too quickly. You'll have a burnt finger or two. Right, that's that done. You see, it says on here, on this instruction leaflet, it says, note, the thicker pins need to heat up longer to get good soldering results. Results. Yeah, they do. A true word has never been spoken. BNC connector, that's in, tick that off. And pinhead and male. Wait a minute. J2, okay, there we go. I'm looking for component designation on the board. It's called J2, which is basically, don't know what I'm talking about. Right, J2. That's going to go in there. This other torch, this other phone, has stayed on properly this time, hasn't it? It's gone off all the time. It switched itself off every 5 or 10 minutes last time. 5 minutes probably. Before having dinner. Now it just seems to be sitting there and staying on. Maybe it's because I asked the G person, the Google person, to do it, and she switched on for me. Maybe she's got some magic way of making it stay on. Computers are strange things, aren't they? Should we say stupid things, because I don't think... I'm not sure if the people that design them all get their heads together half the time. I'm sure the heads are about the bums half the time when they're designing stuff. I say designing in quotes. They call themselves engineers, computer engineers. Yeah, I wouldn't call them that. I call them code twiddlers. Definitely not engineers. Engineering works around known values and constants, and you know, yeah, code isn't that, is it? Definitely isn't. Because every 2 seconds, the so-called engineers, like, they'll release some software 1 week, and like 3 weeks later, they'll change their mind and change how it all works. Well, you imagine if the laws of physics changed every 2 weeks. Oh, tonight 50 degrees centigrade is 50 degrees centigrade, and tomorrow it's 150 because someone's changed their mind. No. Is that on? Looks like it to me. Alright, let's go. Let's get soldering these. This is the last part to do. Soldered. Yes. Soldered. Should I zoom in for you? Where are we? There we go. That's what I'm soldering there. Smouldering iron. I'm so funny. Check those joints from the side. You can never be too thorough with soldering because you've got to get it right. Looks alright to me, me old sport. That metal connector's called right down now. Lukewarm flavour. There's flux all over this board. It's little sparkly sort of little stars all over the board. Sort of white glistening stars. That's flux residue. I'll try and get that off, but I haven't got anything to clean it off with, so maybe I won't. I've got some aftershave. That'll do it. My board will smell lovely of Calvin Klein. Yeah, it's better than nothing, I suppose. Better than nothing. Whoops. What did I do there? I made a bodge job there. I bridged 2 of the pins. Yeah, that's not good. Do you see there? Where are we gone? You see here, just there, there's a solder blob between those 2 pins. There shouldn't be there. So remove that quick as you like. Quick as Flash Gordon. That's gone. Good. Right. One more part to solder or smolder. Yep, let's check that connector one more time. Looks alright to me, Joe. Right then. What's this? Solder ICs? No, I don't think so. This is what I'd have to do if I'd bought the fully unassembled kit. If I bought the kit, which is called the 1502K, 15002 kilo, that would be, I'd have to solder all these little surface mount chips in. Yeah, I don't think so. Not today. Okay. Mount. See, this is the bit I'm doing next. Step 3. I've done step 1 and step 2. Very long steps, about 2.5 hours. Next part I'm doing is this bit here. Mount the small PCB, part number blah blah blah. Yes. Solder rotary encoder. Okay, I'll do that now. This is rotary encoder, this thing here. Oh, you can't see again. That's a rotary encoder. It encodes rotary things. It converts rotary motion into data, basically. Flip it, that's small. How am I supposed to see that? Switch 1 it says. Well, what? I'm trying to work out which way to put it up. It says here, in the red writing, note, please pay attention to orientation of PCB. Use the side with outline marking, which is clearly this side. There's an outline in white. So thank you, Mr. Chinaman, for doing that, because I almost did that wrong. Thankfully I'm taking this at the snail's pace, because I'm not willing to mess this up. There might be a couple of bugs, but we'll soon fix them. There's probably more likely to be software bugs than hardware bugs. This is fun. I'm going to clip this in. Right. Perhaps I'm making a mountain out of a molehill here. Just get on and clip it in. Get in there, you little... Ow! Stab a finger nearly. That's in there. Oh, that feels lovely. That does. What that is rotary encoder turns rotary motion into a signal, also a switch as well, which tells the oscilloscope whereabouts you are in the menu, etc. 1, 2, 3, 4. 1, 2. Yeah, I'm just counting some. So I'm just counting some screws. Right. Let's get that. I can't do that, can I? Let's do that in there. No, that won't work either. Or will it? Hang on a sec. If I'll get me a rubber band from somewhere, I can do that. No, let's use the tweezers, that's a better idea. Get the tweezers. Get the knob of the rotary encoder and jam it in the tweezers, you see. So it's jammed and held in there. Now I can get smouldering. Smouldering hot, baby. Oh, talking rubbish again. Okay. Ow! Just moved my arm and got electric shock. Not from anything, from muscle joints. Gosh. My muscles just sort of twitched and got electric shock. Right. Hey up, lad. You might have to raise the soldering iron temperature again for this. Flipping heck, here we go. Look. Flood it with solder. No, it's okay, this one. This one's okay, right. So yeah, this one hasn't got a large mass of metal behind it. I thought it had, but it hasn't. It's just got metal tabs attached to some sort of spring thing. Majig. What's going on here? Please heat up. I want to get downstairs and eat up. I'm hungry. I'm hungry, mate. I tell you. I'm Hank Marvin, starving. Right. So that's in. So let's get the pins soldered up. Yes, soldered. Nice and quickly. Because this is a rotary part, a moving part. I mean, I don't want to dwell too long on the pins when you're heating them, because it might melt something inside the mechanism and stop it working. So be nice and quick. Like get in there, get it soldered, and get out. Like a bit like an SAS operation, but not quite as risky. There you go. That's that done. Check the old joints with a magnifier. Magnifying iron. Is the camera still running? I don't fancy talking to myself. Yes, good. Right. So I've done that. Now what do I do? Step 1. Assemble front module. Yes, I understand that. Thank you. Step 2. Put your brain in gear. See that module there? There's a hole in the PCB there. As you can see, a big hole here in the middle. This little module here slides in there. And the pins at the back go over that header. And that's what I call a good design. That's nice. I was going to do a Paul Daniels joke there. I like it, not a lot. But I thought I've just done it now anyway. Right.